This is Children's Hospital in Boston, an important battlefield in the war against cancer, and where endostatin was discovered in the laboratory of Dr. Judah Folkman. It was a hard-won discovery. 40 years of complex science that has profoundly changed our understanding of how cancer works. Today, treating cancer often involves extreme measures and some of the most poisonous substances known.
Conventional cancer drugs, most of which are still derivatives of basically the mustard gases used in warfare in World War I and are really toxic to any cell, have the known side effects of you losing your hair, losing your immune response, affecting your intestinal tract.
Unlike other cancer drugs, it's not a poison. So far, it's had fewer side effects than aspirin. Another problem with chemotherapy is drug resistance, which occurs when cancer cells mutate and become resistant to drugs that once worked on them. But endostatin doesn't attack the cancer cells at all. It goes after normal cells, the ones that feed the tumor and allow it to grow. Starving cancer by cutting off its food supply was Dr. Folkman's revolutionary idea, which arose almost by accident more than 40 years ago. With his colleague Fred Becker, Judah Folkman built a crude imitation of a circulatory system and attached a living organ, a rabbit thyroid. When the pump was turned on, the hemoglobin began to circulate. And sure enough, the thyroid gland thrived. Then Dr. Folkman tried something that would turn this blood experiment into a 4-decade quest to understand cancer. To see if the hemoglobin solution could not only sustain an organ, but support new growth, Dr. Folkman injected the fastest-growing cells he knew, cancer cells, harvested from a mouse. Before long, tiny dark tumors emerged on the thyroid gland. Then, the tumors did something almost never seen before. They just stopped growing.
We thought maybe they died, and so to see if they died, we took them out of the thyroid gland and put them back into the donor mice.
To their amazement, the same cells, now in the mouse, came back to life. But why? Why would the tumors grow so ferociously in the mouse, but not in the living thyroid gland? Under the microscope, Judah Folkman could see only one difference.
And the difference was that in the mouse we found many blood vessels had come into the tumor. And in the thyroid gland there seemed to be no vessels growing into the tumor.
Had Dr. Folkman stumbled on one of cancer's hidden mysteries? Did blood vessels play some role in cancer growth?
I had a feeling this is really something important, but I didn't have any idea that it would be some 30 years to try to understand the process by which tumors are able to recruit their own private blood supply and just keep going.
Every time he removed a tumor, he would see blood vessels and wonder if they held the key to cancer growth. By the late 1960s, Dr. Folkman began spending nights and weekends in the laboratory. He was developing a new theory about cancer. He called it angiogenesis, an old-fashioned term which means new blood vessel growth. A tumor, he believed, could not grow larger than the head of a pin without a blood supply. And he suggested the tumor secretes some mystery factor that stimulates angiogenesis, the growth of new blood vessels, which nourish the tumor and allow it to grow. He started devising experiments to prove that tumor angiogenesis was real.